Hello, everybody, and welcome to our video on parallelograms. Okay, so for the purposes of Math 8, let me be completely transparent. We are not going to focus very much on the technical definition of a parallelogram. What you got to be able to do is if you see one show up in a problem, you got to know what formula to use. But I will give you a quick little rundown on what makes a parallelogram a parallelogram. So it has two bases that are parallel, meaning if you extended them, they would never, 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 never touch. And those two bases are congruent, which means they are the same size. Then you have these two other sides that are also parallel, meaning they would also never touch and they are also congruent. All right. And you'll notice in this picture, and this picture is from the Virginia formula sheet. I'm not sure if it looks exactly the same in other states, but this is what ours looks like. There's another line labeled here in the middle with two right angles, and that is the height. And that's the key. The height always makes right angles with the two bases. Okay, and you've got to know what's what because otherwise using this formula is going to be impossible. So I've basically already given you the answers to what all of these things mean, but let's look at this formula here and let's dissect it. The A, I'm sure you can already guess, is for area, and the B is for base because I have already said that so many times. And just like a triangle or a trapezoid, the H is for height. Okay, and this isn't a super complicated formula to use, but I would say the trickiest part of this is knowing what the bases are and what the height is. So sometimes the pictures make it easy for you, and the height looks just like it does in the formula sheet version. So here in this first example, the height is this dotted line that goes right through the middle of the shape, just like it did on the formula sheet. That's my height. And then whatever side it meets with the right angle, that's my base. Of course, the top is also a base, but that's my base. Now, this itty bitty one is actually the same thing, it's just turned sideways. So they still gave us the dotted line, that's the height, but it can get a little more confusing when you're trying to tell what the base is. So look for that right angle. We know the dotted side is the height, which means this other side is the base. And it does have two bases that are parallel, so I'll go ahead and label that one too. But sometimes the parallelograms are not as pretty as they are on the formula sheet. So this last one is almost a rectangle, almost just a regular rectangle because it's so close to having right angles. But there's no dotted line inside of the parallelogram. They have put the height out here on the outside of the parallelogram, which means the right angle is also on the right side or outside, but you can still tell what the right angle would be lining up with, which is the base, which means this is also a base. Okay, because the height and the base have to form that right angle. So the shorter sides would not work. That's the only time it can really get tricky. Using the actual formula for the actual shapes is not bad at all. So let's look at two quick examples. And in both of these, they gave us pictures, so we should be good to go. The first one says, in Hamburg, Germany, there is an office building that is shaped like a parallelogram. Each of these sides is constructed of glass windows. And this is true. You can go look it up, although I don't think these measurements are accurate. How much glass did it take to create each of the parallelograms? So the whole thing would be covered in glass, which is how I know that I need to find the area. So I'm going to write down my formula real quick. No need to memorize these, but I'm going to write it down. And then I'm going to label my picture. So this one is pretty. They gave us the height as a dotted line. And then they gave us the right angle that tells us that this is the base. But here's the part I like best. I like putting my formula into Desmos and then making Desmos do the work for me. So there's my formula, and then I'm going to tell it, hey, Desmos, the base is 120 and the height is 31. And then it's going to give me an answer, and all I have to do is put units on it. So my answer is 3,720, but I got to put a unit because I don't know if I'm talking about dollars, degrees, miles per hour. What am I talking about? So if I look at this question, I'm talking about meters. And you could write the whole word meters out, but I know that meters can be abbreviated with an M. And then anytime it's area, you put a little squared there. So I'm going to put meters squared. And that means literally you could cover this thing with 3,720 squares that were each a meter on each side. Complicated to imagine, but that's what it means. And then we have one more example that is also a parallelogram. This says a local gas company uses signs shaped like parallelograms to mark gas lines. The sides of the sign measure 12 and 30 inches. And they're not labeled for us, but we can figure this out, right? Because the shorter side has got to be the 12, and the longer side has got to be the 30. So even though it's not labeled for us, and I'll write inches on one of them, we can figure that out. If the company wants to outline the sign with black paint, how many inches will they paint? So if we're outlining something, that's perimeter. And I'm going to write that down. Perimeter means add all sides. At least until you get to circles and semicircles, that's what it means. It means add up all the sides. So I'm going to just write it out and then I'll stick it in Desmos. 30 plus 12 plus 30 plus 12. And just make sure it's a parallelogram so you know it has 4 sides. Make sure you've written down those 4 sides and you'll get your answer. 84, and then I know it's inches, so I'm going to write IN, but you can write out the word inches if you want. And that's all there is to basic parallelograms, but soon we're going to be combining them with other shapes, so stay tuned for that, and I'll see you next time.